artificial intelligence. AI, narrow AI, artificial narrow intelligence, artificial general intelligence, and artificial super intelligence. Narrow AI is a type of AI which is able to perform a dedicated task with intelligence. Only one task. The most common and currently available AI is narrow AI, is the world of artificial intelligence that we are living today. Dedicated task it can do. Narrow AI cannot perform beyond its field or limitations. And as it's only trained for one specific task. So it's also termed as weak AI. Today, we are producing only weak AIs, and we are successful for producing narrow AIs. It operates with a limited predefined range of functions. IBM Watson supercomputer, for example, like a supercomputer, IBM Watson, it's also a narrow AI. Next, general. Did I come to general AI? Please click. General AI, it's another type of intelligence, artificial intelligence, which could perform any intellectual task with efficiency like a human. The idea behind the general AI is to make such a system that, well, which could be smarter and think like a human by its own. That's the thing that people are scared of. People are scared of, oh, AI is going to control us. We are not in that era yet. We are not in that phase yet. This AI is coming, but we haven't done it yet. Currently, there is no such system exists which could come under general AI. I can't give you any examples for this, but they think that it is smarter and think like a human, can estimate things, has got feelings. Right, just think like that. Next, super intelligence. Can I go there? Super AI is a level of intelligence of systems at which machines could surpass human intelligence. Now, just think they are better than us and can perform any task better than human with cognitive properties. It's an outcut of general AI, actually. Super AI is still a hypothetical concept of AI. Development of such system is is still world-changing. It's a game changer. AI, I mean, if you have come to super AI, even general AI is a game changer, but super intelligence, believe me, it's a true game changer. I don't know if you can't see that, but things are improving, developing very fast, so I can't say no these days. But the way we are going right now, I don't think that will take us to general intelligence, maybe general intelligence, maybe, but not super intelligence. We should change the paradigms. We should change what we are doing right now. We should find some other things that I will teach you in this course. With the things that I will teach you in this course, you can't do super intelligent, artificial intelligent agents. You can't do that. But I know how to do that, but I won't tell you. In 1960s, we had naive algorithms, and then machine learning, and then deep learning, and deep reinforcement learning. And today, we've got distributed agents, swarm deep reinforcement learning. So with these things, naive algorithms, you can't do anything. Machine learning, well, you may think that you can create general AI, but I don't think that. Deep learning, no. This algorithm is not enough to create a super intelligent agents or general intelligence. It's difficult. Deep reinforcement are the same. But this one is coming. 2022 is the starting point of it. Distributed agents. Agents, I mean, artificial intelligence agents are not learning in your computer. They will go somewhere on another's computer, learn there using their own data, and come back to your system to put them together. Then general AI will come. With today's technology, today what we are doing, we can't create it. What we should do is send your agents to everybody's computer. They would like bees, like ants, maybe honeybees are good examples for that. Collect something and come to the hive and make the honey, make the general AI. Then we can do that. But today, we are still doing everything in our own computer. We get the flowers from the gardens, from everybody's computer. We put them in our computer, flowers, and our honeybees are working here. But the future should be let the flowers stay what they are, where they are, and we will send our agents, honeybees, create things, collect things, pollens, whatever, come back to the hive and put them together to learn, to teach themselves. That's it. If you can't do this, we can never reach what we call it, general intelligence. Subsets of artificial intelligence. First of all, we've been talking about it. Machine learning, deep learning, natural language processing, expert system, robotics, machine vision, and speech recognition. These are some of the subsets of artificial intelligence. For more details, machine learning, actually deep learning is a part of machine learning. There are some algorithms under them. Expert system, natural processing language processing, NLP, embraces text generation, question answering, classification, machine translation, context extraction, speech recognition, well, speech to text, text to speech. Again, we've got planning, robotics, vision. So if you say that I'm interested in AI, which part of AI, I will ask you. Are you interested in deep learning, machine learning part on it, or text generation, classification, machine translation is a part of AI, or is it machine vision, image recognition? Is it the area that you are interested in or you're dealing with, or text things? So AI has got many things that we should consider. Machine learning, let's learn firstly this one, is a part of AI which provides intelligence to machines with the ability to automatically learn with experiences without being explicitly programmed. They will learn from data. This is the process that machines learn from data through some algorithms. That's maybe the simplest definition of machine learning. It's primarily concerned with the design and development of algorithms that allow the system to learn from historical data. It is based on the idea that machines can learn from past data, they can identify patterns, and they can even make decisions using these algorithms. Machine learning algorithms are designed in such a way that they can learn and improve their performance automatically. Yes, they are designed in this way. Few of them are doing this. Few of them are doing this. Again, human beings are intervening with the system, the process. Machine learning helps in discovering patterns in data. So what do we understand? The keywords of machine learning are algorithms, past data, learn themselves. That's it. Natural language processing, NLP in short, is a subfield of computer science actually, and also it's a subfield of AI, artificial intelligence. NLP enables a computer system to understand and process human language, real human language, such as Turkish, such as English. NLP plays an important role in AI as because if you don't have NLP, an AI agent cannot work on human instructions. But it must be a part of the AI system so that when human gives some instructions, the computer, the machine should understand it, the AI should understand it. Today we are all around AI, and as well as NLP, we can easily ask, Siri, Google, or Cortana to help us in our language. But they are still primitive, but they are good examples of NLP as the subfield of artificial intelligence. Yeah, the input and output of NLP applications or agents can be in two forms. They are speech or text. Both work for this one. Deep learning, it's again a subset of machine learning or AI, which provides the ability of machine to perform human-like tasks without human involvement. Human-like tasks without human involvement. It provides the ability to an AI agent to mimic the human brain. Deep learning can use both supervised and unsupervised. What is this? Supervised and unsupervised. First time you hear this word. Supervised and unsupervised learning to train an AI agent. Deep learning is implemented through natural networks architecture, so also called a deep natural network. It comes from artificial neural networks, but artificial neural networks inspired from real human neural networks. So a deep neural network term will be good, will be okay for deep learning. But today, I think people are using deep learning. Yes, deep learning is mostly used. Deep learning is the primary technology behind self-driving cars, speech recognition, image recognition, automatic machine translation, and so on. The main challenge for deep learning is that it requires a lot of data with lots of computational power. That's the challenge. You need a lot of data and lots of computational power. This is what deep learning. We will examine deep learning and machine learning later on. Expert systems. An expert system is another application of AI, artificial intelligence. In AI, expert systems are the computer programs that rely on obtaining the knowledge of human experts and programming that knowledge into a system. Take from human experts and convert it into AI, and convert it another computer system or program, software. Actually, expert system emulated decision-making ability of human experts. Yeah, emulation. These systems are designed to solve the complex problems through bodies of knowledge rather than conventional procedural codes. They get things, experiments, knowledge from the users and use them to make decisions rather than using conventional codes, Python codes, C codes. That's different. One of the examples of an expert system is a suggestion for the spelling error while typing in the Google search box. The codes behind this suggestion, spelling suggestion, may not more than half of an A4 page. Maybe one page codes are enough for this one, but there is knowledge behind it. So the computer is taking from that repository, knowledge repository, and suggesting you. This is a good example of expert system. The characteristics of expert systems: high performance, very fast, reliable, high responsive, and they are understandable. These are the characteristics of expert systems. Next, another subfield, robotics, is a branch of artificial intelligence and engineering, which is used for designing and manufacturing robots. It encompasses two things: AI and engineering. What engineering? Mechanical engineering, electronic engineering. What do they call it these days? Mechanical engineering and electronic engineering, and some part of computer engineering. Mechatronics, yeah, mechatronics. Computer engineering, electronic engineering, mechanic engineering, whatever. So in simply we can say it's a part of AI and engineering. Robots are the programmed machines which can perform a series of actions automatically or semi-automatically. They are the machines. AI can be AI can be applied to robots to make intelligent robots which can perform the task with their intelligence. So we can produce an AI and produce a robot to make intelligent robots. You can say AI algorithms are necessary to allow a robot to perform more complex tasks. Nowadays, AI and machine learning are being applied on robots to manufacture intelligent robots, which can also interact socially like humans. Sophia robot is one of the good examples of that. Computer vision or machine vision in general. Machine vision, to be more specific, machine vision, it's an application of computer vision actually, which enables a machine to recognize the object. Should recognize the object. Machine vision captures and analyzes visual information using one or more video cameras, analog to digital conversations and digital signal processing by doing. Machine vision or computer vision exploits image processing. Image processing is not computer vision, it's not machine vision. Computer vision, machine vision, uses them. Machine vision systems are programmed to perform narrowly defined tasks, narrow artificial intelligence. Remember that? Such as counting objects, reading the serial numbers, etc. Today, they are very successful for narrow AI, so that they can read, they can translate, they can count how many people are, they can count how many cats and dogs are in the picture or in the image. Now they've just started to understand if the cats in the picture are hungry or not, happy or not. Now things are going to that way. With the help of machine learning and machine vision, an AI agent can be able to see through walls. I wonder if we can see those days. Speech recognition Okay, it's a technology which enables a machine to understand the spoken language, human language, spoken human language, and translate it into a machine readable format. It can also be set as automatic speech recognition. They also call it like that. Or sometimes they call it like computer speech recognition. It's a way to talk with a computer, actually. And on the basis of that command, a computer can perform a specific task. It's a part of NLP, but it's more detailed. They are in between them, so speech recognition, text recognition, NLP, text mining. They are sisters and brothers. There is some speech recognition software that we know. They are limited. They have got limited vocabulary or words or phrases. This software requires unambiguous spoken language. I mean, you must be plain, clear when you are talking to that computer. Don't make complex sentences yet. In time, they will learn, because when you're talking to them, to those machines, Siri, for example, Cortana, if you make small sentences, plain sentences, they understand you better. But don't forget, at the same time, they are storing data and learning. It will help them learn better. We need to train our speech recognition system to understand our language. In previous days, these systems were only designed to convert the speech to text. But now there are various devices which can directly convert speech into commands. I don't know if you are watching me right now with subtitles. If you are doing so, you are using speech recognition. It is converting my sayings, my verse into text format and displays it. Next step may be translate it into Turkish or in other languages. And next step maybe think that what I am talking about. Okay, this is, am I talking about AI? Am I talking about speech recognition? Or am I talking about politics, sports, etc., or arts? And next step again will be, am I talking about good things, bad things? Am I angry or not? I'm happy. Sort of things may be used. What are the goals of artificial intelligence? First, replicate human intelligence. Next, solve knowledge-intensive tasks. An intelligent connection or perception of action. Building a machine which can perform tasks that require human intelligence, such as proving a theorem. We can use artificial intelligence to prove a theorem. Play chess, we know that. Plan some surgical operations. Well, they are helping doctors now. Driving a car in traffic, we are doing that. These are some of the tasks. Creating some system which can exhibit intelligent behavior, learn new things by itself, demonstrate, explain, and advise to its user. What are the advantages of AI? High accuracy with less errors. AI machines or systems are prone to less errors. They can't make less errors. I mean, we can't say that they don't make any mistakes, but we can say less. And they've got high accuracy as it takes decisions as per experience or information, because they depend their decisions on pre-existence, pre-exist or existing information. High speed, we don't need to talk about it. An AI system can be of very high speed, and they can make very fast decisions. Because of that, AI system can be the chess champion in the chess game. High reliability. AI machines are highly reliable and can perform the same action multiple times with high accuracy because they have got no stress. They are not stressed. They are not scared. They are not afraid. They are not unhappy. So they repeat the same thing again and again, multiple times, without making any mistakes, we can say. They are very useful for risky areas. Like AI machines can be helpful in situations like diffusing a bomb, exploring the ocean floor, or any other dangerous places where to use a human can be very risky. So this is another advantage of AI. They may be digital assistants in your pocket. You may carry them. It's currently used by various e-commerce websites to show the products as per customer requirement. We see it in e-commerce websites. They may be useful as public utility. AI can be very useful for public utilities such as a self-driving car, which can make our journey safer and hassle-free. Face recognition for security purpose. Again, it's another public utility. Natural language processing to communicate with the human in human language. I tried this one when I was in Greece. There was an old lady who didn't speak English or any other languages rather than Greek. So I didn't speak Greek. So we used, I think it was Google Translator on my mobile. At the beginning, it was difficult to tell the old lady that she should speak to this mobile phone, and the mobile phone will translate it to me, and I will talk to it. And at the beginning, it was a little bit difficult, but later on, she also figured it out, and of course, it wasn't chatting for hours, but for asking for something. I mean, it was the landlord actually. She was the landlady, the landlord of our apartment, and I was asking some utilities, kitchen utilities. She didn't understand me. That's why we used that. And we, of course, have got some disadvantages of AI. Every technology has some disadvantages, not only AI. And the same goes for artificial intelligence. Being so advantageous technology, still it has some disadvantages which we need to keep in our mind while creating an AI system. High cost. Yeah, the hardware and software requirement of AI is very costly as it requires lots of maintenance, power to meet current world requirements. Can't think out of the box. Even we are making smarter machines with AI, but still they cannot work out of the box, as the robot will only do that work for which they are trained or programmed, narrow AI. They can't get out of the box. They stay there and does whatever you tell them. They have no feelings and emotions. AI machines can be outstanding performer, but still it does not have the feeling, so it can't make any kind of emotional attachment with human. They're robots, machines, and may sometimes be harmful for users if the proper care is not taken. Increased dependency on machines. Is it true? As we got dependency on our mobile phones, we got dependency on the internet. With the increment of technology, people are getting more dependent on devices, and hence they are losing their mental capabilities. I couldn't say that. I remember I used to keep in my mind the telephone numbers of my friends in my mind. Now I can't. I know only a few of them, but I remember I memorized more than 50 telephone numbers and addresses. We are dependent. No original creativity. As humans are so creative and can imagine, can dream some new ideas, but still AI machines cannot beat this power of human. This power of human intelligence is very important, and machines cannot be creative and imaginative. They can't dream. That's the key word. We dream.